to Advent of Code Day 18. I've been using a language called fstar to try to solve Advent of Code problems. And yesterday I did not get either star. So I'm going to try. I started the stream a little early today to try to go back and see if we can finish that up before solving Day 18's problem. So thanks as usual to all the sponsors of Advent of Code, including my employer, Akita Software. You can see our little ASCII Akita in the bottom right-hand corner. Check out the links to our job page. So the thing I was trying to do is come up with bounds for the search. So I'm not proud. I looked at other people's solutions and I found a lot of sort of ad hoc bounds, like okay, the maximum Y velocity can't be greater than 1,000. Let's just search them all. Which seems a little, it seems a little ad hoc to me. There doesn't seem to be any fundamental reason why, since the, all right, I should put the picture up so you know what we're talking about. So we're firing a probe and it slows down due to drag and it increases in y velocity due to gravity. So as this picture shows, we can actually come to a halt and then drop down into the target zone. So it's not obvious that there's any upper bound on the y velocity and thus how high we can get at all, right? Maybe we can always, find larger and larger y values that just on their way down happen to step into this region. There's no intuitive reason to think that's not the case. It's probably not the case because the problem has a solution. But how do we know that it's 1,000 and not 10,000 or 1,000,000? Six digits would be totally reasonable as an answer. Okay. So lesson yesterday was don't do algebra when tired. I am still tired, but I'm back at home now. So there's an obvious bound on x. We can't have the x velocity be greater than the maximum in our target range, or else we'll overshoot right away, and there's no way to come back. So we proved this is the closed form version of the y position, our initial velocity yv and the times on end. So if we take the target range as bounds by a and v, we can just do some algebraic manipulation and get this inequality. So this is helpful because it says we've got a bound on the initial velocity in terms of n, which immediately doesn't sound like it helps because n could be anything, right? But the thing to notice about this bound is it's n minus 1 over 2 on both sides, and then it's something that gets very small as n gets larger. So n minus 1 over 2 is either an integer or half an integer. And importantly, in the input we've been given, they both have the same sign. So eventually, that interval is not going to contain an integer. It'll be either, n minus 1 over 2 is an integer, but the difference between an and bn is, to the right of that integer, or it's a half integer, and it's not enough farther over to reach the next integer. So that gives us an absolute bound on how big n can be, and from that we could figure out how big y could possibly be. So can we prove this to f-star's satisfaction? Because that's what I've been doing. Is can we if I've made a mathematical proof, can I check the proof in f-star? So the trivial proof here above, f-star can handle without any help from me, right? I just say, okay, well, the maximum x velocity is x max, and it can verify, yes, if for all n greater than 0 and velocities, if we manage to hit the target range in the x component, then the velocity has to be less than that computed maximum. And we, like I said, we didn't need to prove anything else. F star farms out the heavy work to Z3, which is an SMT solver, and it says, yeah, that's true. So here's I think the bound above in that that this reasoning says is gives us a maximum value of n. It might not be the best bound, but it's at least a bound. So we want the difference between the two divided by n to be, for a solution to exist, that bound has to be greater than 1/2. So the problem is my reasoning above here used real numbers, and the SMT solver, I think, is going to be happiest if we work for an integer. So, writing the corresponding lemma here, just like we did for x, cannot be automatically solved. So let's see if we can prove that that's actually the correct formula, or come up with the correct formula if that is wrong. So my usual way of going about it when I don't know what F star can prove and what it can't is just write some assertions and see where it stops agreeing with me. So we can just say, well, that condition that we hit the target implies, where is our closed value? Let's just do half. Let's just look at half the condition. So that says y min less than or equal to the closed form we managed to prove yesterday. Right, so that's just unpacking the definition. We need to fix the name here. All right, so it didn't flag this assertion. It just said I can't prove the whole post condition. So that's true, which is obvious. That's, like I said, that's just unpacking the definition. So what we said next in our reasoning was we moved this to the other side of the inequality. Oops. So if we're in range, then that should be logically equivalent to our previous statement. What's he complaining about here? Extra parenthesis. Okay, good. Haven't gotten too bad yet. So I'm a little worried that that this step won't follow. So we're going to multiply by 2 throughout to get rid of that denominator. And since this is integer division, it doesn't actually follow. that it should, because this number is n minus 1 times n is always divisible by 2. Okay. All right, we're still good. We'll be in trouble when it flags particularly one of these assertions, or we convince it that we got all the way done. All right, so I don't want to divide by n because that'll take us out of integer operations. So no, we can divide by n. I think. Let's give it a try. Okay. All right, still good. All right, so let's go to the other side. So we're going to say, on the other side, we'll say I think that's right. Oh, unknown. Oh, get hit timed out. All right, so what we're going to do is we're going to give the solver more time, which we had to do yesterday too. What did that look like? Oh, I didn't switch from min to max. Don't like that we've gotten unknown assertion failed rather than the message we were getting before. I think there might be an option to send the queries one at a time. Okay, I'm going to get rid of these queries since we don't need them anymore. Okay, I'm gonna leave them commented out in case I went off the rails at the last minute. All right, so this one is wrong. Is my math here wrong? Oh, okay. No, so when I divide by, okay, this was the problem. I only divided this term by n and this term by n, but not this one. But still said that was okay anyway. All right, and that's the problem. Is if I divide by n, I'm not sure that. Not sure this will work. I really don't want to give it this much time every go around. All right. Maybe it'll be true for integer arithmetic too. All right, it seems happy with that. Let's see if the opposite works. It's just not very friendly about when it can't prove something, doing a good job of telling us what it was. Let's see. So is this? I guess the fact that it rounds down shouldn't matter. So if we combine these two, we should get I don't remember the relative prioritization of implies and. I was seeing something about. I'm looking in the certs. Oops. Cert spinoff. All right, let's try that. Oh, we gotta wait till this finishes. It's very easily be the case that I made a basic algebra error, but I don't see it. All right, let's do assert spinoff. I shouldn't have good in on 120 limits again. I haven't made much progress, and it's open almost the new puzzle day. See, there's the Z3 solver running its own process, churning away at the CPU. Yep. Z3, I don't know if Z3 can be set up to use more cores. That seems like an obvious thing to do. I guess the answer is All right, maybe. No help on the wiki. Ooh, that's no good. Okay. Okay, so we could probably Set a custom option to Z3 and specify the number of cores and see if that works. All right, a couple more minutes here. All right, so how do we express, how do we get from here to here? I mean, this might, yeah, the problem is we require this division to be non-zero, and for sufficiently large n, the integer division will just get rounded down to 0. So this doesn't help us. So we need to somehow keep all the n's in the numerator and still get the same result. So it should be that we can just, all right, what does that look like? Well, we know it must be the same bound must apply, but how do we reason about it? Maybe just go back to this version. So that's equivalent to n times y minus. So can we prove that? So I think we could prove that this, when n is sufficiently large, that this is going to exceed the bounds. All right. Well, I will keep working on that, but let's take a look at today's puzzle. All righty. So if you're just tuning in, welcome to Advent of Code in F star. This is day 18. I had been working on the day 17 puzzle, which as you see, I still did not solve because I'm trying to make a very rigorous proof of it rather than just spray and pray. Right, we need to help out the smaller snail fish with his math homework. Every snail fish number is a pair, an ordered list of 2 elements. Each element of the pair can either be a regular number or another pair. Okay. Well, I had been thinking of trying to implement surreal numbers or the bigger class of combinatorial games in F star, and this actually feels like a lot more complicated. Okay. Is nested inside 4 pairs. What does that mean? Does that mean the depth of the tree? Left no such pair. Hmm. All right. Well, we can at least start by writing a parser. Okay. The thing I wanted to check, yeah, all these are, if not reduced, they at least contain no digit bigger than 9. So we don't have to get too fancy in our parser. And come on. All right, so we just wrote a recursive descent parser over bits in day 16. So, all right, so we're gonna do a lot of the same sort of stuff. All right, we're gonna need our usual suspects. I'm not sure we're actually gonna need string. Yes, we're at least gonna need to convert the input strings into lists of characters. So, all right, so all right, so I'll just call it a number. Say snailfish number is either. I think it's easier to violate the definition a little bit, but I'm worried this will get me into trouble. It's easiest if we say it's either a literal natural number uh, or it's a pair of numbers. So that violates technically what we were told, that numbers always have to be pairs, but Otherwise, we'd have to say, well, is it a pair of base numbers or is it a pair of other numbers? So I think this is the right way to do it. All right, so we're going to build our recursive descent parser. And the input's going to be a list of characters. And so to make this a total function, all right, let's do the same thing here. We'll copy. We'll create a parse result type that will be either OK and it with a value, and we'll fill in the value will always be number, and the unparsed characters so that we can continue parsing, or it's going to be an error, which we shouldn't get, but that'll help us debug if I screw it up. So this is going to be parse number. All right, so if the length of if it's 0, then we're done. Which again shouldn't happen. We should end with a close parenthesis. So our number is either going to be a literal, in which case it's a single number, or it's going to be the start of a new pair. So match. All right, we're gonna use the short version of everything. Index 0 of index. Okay, I think that's the right order. It's not muscle memory yet. So it's either going to be a open square bracket, in which we're going to say parse a pair starting at. Oh, all right. That's what we need from this as well. We need our functions to. I think we just need the functions to take suffixes of a list. So there doesn't seem to be anything like that in the F-star standard library. There's one for substrings, actually, but sublist you can actually prove something about, and substrings you cannot. So I actually, if you look in my repository, I have a parser combinator library that operates on strings, and I had to define what the behavior of substrings are in terms of this sublist function. Okay, so we're going to give it all the input, or just the one let's do just the one past the first character. So suffix skipping one character of the input. Okay, and then all these are going to be a OK parse result where the number is a literal 0, and the rest of it is suffix 1 input. So we're just going to copy that. I better get the syntax right before I copy it. 1. Come on. There we go. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. F-star does have ways to convert characters into Unicode code points and operate them as U32s, but it's more trouble than it's worth for just 0 through 9. All right, and if we get any other character, then we'll say unexpected character. And can we easily convert this to a string? Sure, let's do string of list, a list containing just our character C. All right. All right, so, and we're gonna parse a pair. So this is how we do mutually recursive functions. We put them all in one big letrec clause combined with and. So all right, so if it's a pair, then we got to parse the first number and eat the comma and parse the second number. So this is where we get into the termination problem. So we decrease the length from the first one to the second one, but then we're going to go right back to the first one. So we solved that yesterday with a custom metric. I'm not sure which way I want to do it here. So all right, let's do it this way. So this function, its metric is the length of the input comma 1. So it can call this function with the same input length comma 0, and then we'll call the original one with a lower length. So we'll put in the whole input here, which is now allowed. And so we'll say, okay, so the left result equals parse number on the input. And if we get an error, it just pop the error all the way back up. We could do other things there, but that's the simplest place to start. And if we got a okay result, then that gives us a value and a remaining. And what we want to do with that is check that there are enough remaining characters, and then the next one is a comma. Okay, so if length of rest1 is less than 2, and we say error Oh, we didn't eat the we didn't actually eat the square bracket yet. So maybe we could have got by. Maybe we could have got by without the metric, but it should be harmless. Okay, so we eat the square bracket by taking the suffix. We parse that recursively. We get whatever is left of the string. That needs to start with a comma. So else if index rest1 0 not equal comma. I'm going to have to put this in parentheses. So the caret sign is string concatenation. All right. So we got our comma. What we want to do is get a right result. Suffix 1 of rest 1. All right, and again, if we have an error, just pop it back up. Otherwise, we got a second value and the rest of the string. And so we need to find the close bracket. So another level of nesting here. We could break these up into more functions or helper functions as long as the mutually recursive part is all part of this. So like we could do the checks here. Okay. All right. So if all that passes, then we must be. Oh, we need to check rest 2, not rest 1. Okay, so we have a pair of value 1 and value 2, and let's take the suffix of that. All right, I think that's our recursive descent parser. Let's see how many syntax errors we've got. A bunch. Okay, missing colon. I have not decided. Okay, match. Huh. Alright, what's the problem here? well, did I get the and syntax wrong? No, well, looks right. Huh. All right, well, if all fails, try to isolate where the problem is. Okay, so oh, all right. I didn't need let statements there. That was the problem. So it was looking for the in after the let, but we don't actually need to assign those to anything because we're extracting the value from the pattern. All right. Okay, that is index rest1 0. Okay, so this can only be called on non-empty lists. Let's try that. Okay. Okay, so the problem is how did I solve this on day 16? Because I know how I solved it in the general parser combinator library. Maybe it did not arise in the same way. The problem is that while we know that we it doesn't know that this is shorter than this. Rest1 is just some string it got back. And how does it know that that is short enough? So what I've done before is include the input here, and then we know what the rest is strictly shorter, which prohibits us from doing zero length parsers, but that does not arise in this case. So maybe that's the most straightforward way to convince it that. Oh, I know what I did before. Is I just checked for it as an error case. I'll make that bigger. I just instead of making it part of the type, I just checked for it, and it was an error if the length didn't get shorter. So let's do it the fancy way today. All right, so we're gonna say this takes a context that is a list of characters. We don't need it for the. We don't really need it for the error type. Okay, so far so good. So what we want to do is say this is not just any list of characters, but it's a list of characters whose length is strictly less than the context. So we could go further and actually require that it be a suffix of the context so that the parser didn't just give us some random string. But for termination, that's all we need. All right, so this needs to be a parser result on number with input as its context. And this is the same. And so for OK, we need to say everywhere we've got an OK, we need to change that to OK input. Right, and it should be able to verify that in every one of those cases, this doesn't seem. Okay, we definitely need it there. We might need it in pattern matching. Oh, what happened there? Okay, we do need the input, the context, so we can match the type. Kind of silly. I actually wonder if we could make this a implicit argument. Let's try that out. Ah, that worked. All right. Good deal. So, it checks that it returns the right type and that it terminates. Because we didn't make any more sophisticated guarantee about its results. But that's not nothing. All right. So let us write an unparser because we're gonna need to do a lot of work. So unparse number so that given a number returns a list of characters. So if it's a literal, then we print the number. Oh, this is a pain. And we have to convert that to we have to import. Oh no, it is there. All right. We have to convert it to a string and then convert it back to a list of characters. So, and if it's a pair of left and right, then we can use string concat. What am I trying to do here? There we go. We can use string concatenation. I may have been happier doing this as string rather than list character, but the reason I wanted list character is so that we could at least conceivably say parse and unparse are inverses. Okay, unparse number r at. All right, that was considerably simpler. And it type checks. All right. So let's write addition. All right, addition is easy. Add numbers, A number, B number, get a number is pair AB. All right. So now we need to reduce the number. So we need to we need to do the first action in this list. So we need to go down the left-hand path first and find the first thing that applies. So if a pair is nested inside. All right. All right, we should be able to use pattern matching. Oh, yikes. All right, yeah, this example shows it's a little hard. So we can't use pattern matching because we'll have to. So 3, 2 explodes, and the 7 goes up just one level, but the 2 goes up several levels. All right. So how are we going to do this? So we're going to search until we find a do a leftmost search until we find a deeply nested pair. And then we're going to push those values back up. So we need a return type, kind of like we did for parsing, but hopefully less complicated. I'm just copying this because I can never remember the syntax. All right, so an explode result is either none, I don't want to use that because it overlaps with the optional constructor name. Maybe we should just use optional. I think we have to tell when we've used each part. That's my theory anyway. All right. So not found. All right, not found. Uh, oh, this is too many cases. All right. So one option is to have left, and right. Another is have left, right with two optionals. I think nesting it is going to be a pain. So left int. Did we say these were ints or natural numbers? We said they're natural numbers. All right, that's good. Colon. There we go. All right. So when we explode a number, we return an explode result. So we need a depth. All right. If the depth is nested 4 deep. I'm unsure how to count. That is the problem here. Nested inside 4 pairs. So does that mean it's the 5th pair? Yeah. So 0, 1, 2, 3, 4. I'm starting to wonder if it would have been better to check literals instead. I'm going to have a heck of a time proving that this process terminates. All right, so if depth less than 4, then I'll just do this whole thing here. Maybe we can refactor it. All right, so if we've got a literal, it's not found. If we've got a pair AB, then we want to all right, we want to try to explode down the left branch, and if I feel like this is going to be somewhat redundant. All right. So we're going to match explode number A depth plus 1. So we traverse down the left branch. If we get a not found, then we want to do the same thing on the right branch. And I don't know how to, I'm not coming in with a good idea of how to encapsulate the code in the two cases. Because having it nested like this is gross. Well, let's write it out and see. All right. So if we finished, then we just return. No, our result type's not right. If we modify a pair, we have to return the modified version. Okay, so what order should these be in? Okay, so if we've got both a left and a right, it's because we exploded the pair and there's no replacement. I kind of feel like maybe left should be on one side and right should be on the other. Let's do that. Hopefully that won't create more confusion than it needs to. All right, so now our explode result includes the new subtree and any leftover information. So if we finished exploding the number, then just return the subtree. But we don't go down the right subtree because we already finished. We're already done. If it's the immediate child that exploded, then we were going down the left subtree. Okay, so this case looks like left comma right me. So n equals left comma right comma b. There we go. How does explosion work if b is a... Oh, gross. So if b is a normal number, we just add to it. But if b is a tree, we gotta send down that tree looking for the leftmost node to add it in. All right. So I'm wondering if we can actually simplify their cases some, given that we're going to have to write some other functions. So we're going to return left with L, because that can only be handled at a higher level. And we're going to add to leftmost B of R. So we're going to descend down that tree and add B to the rightmost, and that is no, I think I'm missing something. Okay, if we have numbers on both sides, then we can add them both. If we don't have a number, I'm just... Okay, how do we tell when we need to replace it by a 0? Oh, then the entire exploding pair is replaced with the regular number 0. All right. So All right, for at this level, then it's going to be pair of literal so it's 0, comma, b plus r, and a left still to be added. Okay. God, that seems to, there's got to be a better way to represent this. Probably is an imperative programming language. We can just walk up the tree and back down and fiddle with it, but I'm not. I think we just gotta push through here. All right. Okay, so if we exploded something and it's coming back and says, I have a left to add, we went down the left branch already. So we're going to have to go up further and okay, so this means add left to the literal immediately left of the results. Add right to the literal immediately. Okay, so we can't add it here because this was the leftmost element we knew about. But the tree is now the pair with NB. ASCII diagram time. We shouldn't use N. I'm going to use X at the top level. Okay, so X consists of A and B. A is now, when you descend down A, it says, hey, I'm N. I'm now L and N. So X is now NB, and we got to keep moving up. All right. So if it's write an R then we need to then we can resolve it. We can finish the pair that is the new result and add to leftmost B and R. Okay. All right. So all those are all 5 cases. Otherwise, we try to explode down our right-hand branch. And there, if it's finished, we just return that. If it's not found, we say not found in that subtree. If we have left okay, we went down B and said, hey, I've got a new node that replaces that and a left. Then we can finish it by saying pair add to rightmost AL and the replacement N. Okay, and we might get right. So that we can't handle right away. So we return right. Pair AN, and we still got that right value to try to push up. All right, 1, 2, 3. Okay, and we have left, right. So that looks like okay, so we got a left value and a right value and a 0. So we can take care of the left value right away and defer the right value. Add to rightmost AL, and a literal 0, and the deferred R value. Phew. All right, we're going to need some parentheses in here. Just for my own sanity, if for no other reason. Okay. So the problem is we gotta do all these other cases when our depth is 4 or greater as well. So it'd be awfully nice to not just copy and paste that. That's a lot of work. So the problem is we want the pair literal case. No, I think we can do this. All right, so what we can say is if we've got a pair literal A, literal B, then either we explode that or it's not found depending on the depth. And we haven't been, well, we haven't updated the depth. All right, so if the depth is greater, let me count that again. 0, 1, 2, 3, 4. Then explode it, else not found. All right. Okay. So I think we just need to write the add to leftmost and add to rightmost, which don't actually need to be. All right. Okay, so yeah, so if we're already on the left side all the way up, then we just drop it. That's what it said to do. All right, so if we're a literal, then we and we're a bigger literal. Otherwise, we're a pair. And so we return the pair of add to left most A to add with the right branch P. Oh, I need a match statement. Match. Okay, that was not too bad. And here we just swap them around. Add to rightmost. All right, let's see if we can write. Oops. Okay. Let's see if we can encode one of these examples and see if it works. All right, that's a pair. All right. So, do we have equality on our parse results? We should. On our explode result. Okay. Explode number example 1 starting at depth 0 should be equal to that becomes a 9 and that becomes a literal 0. What's it complaining about? Oh, okay. We expect this to be a finished. All that. Maybe we should have started with an earlier. No. Okay. We should have started with an easier example. All right. Well, I wasn't seriously worried about that case. Let's create a print statement. Let's create a helper. Print number. Print string. String of list unparsed number. Okay, so let's print out what we actually did here. Print load. It's a very slow way of debugging. Huh. I didn't tell it to use the hints. Let's set that up. Oops. We're in the wrong directory. That will hopefully speed things up a little bit. The hints are what's called the unsatisfiable core from the 29234. That looks okay. All right, simple mistake. We didn't say that. I used the wrong type. Left. Okay. So what are the other examples? Let's do this one. So we should use our parser. Equals parse number. All right. Get rid of the other days. This adds a lot of complexity because we gotta check the error code and all right. Let's just okay. All right. Okay. Otherwise, we get okay. Get the val, and we don't care about the rest. Oh, we can't call that val. That's a keyword. We want to print explode of. Want to do that. What's going on here? Oh, missing parentheses. Why didn't that work? That's the wrong example. I'm not asking to print it out anymore. Oh, okay. Yeah, that would help. There we go. All right, does that look correct? It does. All right, so let's do that one. And that one. Print number. Oh, okay. That looks okay. 21723. Okay, that looks good. Oh, I should explode it a second time. All right, looks good. Now we have to implement the split operation. We don't need to keep these around in the output. All right, so so this should be more straightforward because we don't need the depth. We're just going to return a number, but we still need to know, did it do anything or not? Yes, split does look like it's a lot easier. But we can't reuse the same names, damn it. Uh, uh, the leftmost split. Okay. So if all right, so if this is a literal V, A, then if A is greater than 9, then we finish the split with a pair where the first half is okay. We round down by default. We'll round up on the other half. Okay, else leave it be. Okay, then otherwise we got a pair AB. So we try leftmost first. So match number A with, if it's a finished split, then I'm gonna call those left and right, split the left. If that's finished, then rebuild the pair from A and the right. And not found split, then we I wish there were a nicer way of sequencing these, but I'm not going to start writing a combinator library at 30 minutes after midnight. Okay, then we basically do the same sort of thing for right. Left. So if you finish a split on the right, we return original left in the replacement, otherwise not found split. What? Oh, I have to wrap both those in literals. Okay. Might as well check the test cases they gave us. All right, so check example split. Okay. So example 5. There we go. what was the other split example? That one. Huh. Well, what's going on here? I think my KVM just died on me. Just a sec. There we go. Something a little odd is still going on here. Why can't I click on anything in Windows? There we go. When in doubt, pull up the task manager. All right, my screen share stopped. Well, that was strange. All right. Should have a technical difficulties screen. Except this has been nothing but technical difficulties. All right. That is the version I was trying to use. Finished. What? Oh, these don't parse because they're too big. Because I specifically said those were errors. Well, at least I know the error parsing works. All right, let's convert these. All right, so this is pair. Right, the final pair is pair literal one, literal one. The next pair. split up that way. All right, I think that's right. It says it's not. Okay. All right, we've got. I should have kept the original. All right, 0, 7. I think that was the problem. And 4. And 15. Okay. 1, 2, 3, 4, 0, 7, up 1, 4. What's that? Oh, I see that. There we go. After the split, 7, 8, 0. All right, that looks pretty good. And what we can do is just split. And split it twice. Okay, so and if should I call it? Finish split. Split. Dot n v else. Okay. That looks pretty good. So let's now we need to sum and fully reduce. Okay, so I think we need to reduce them after every add. So the thing that would be very challenging here is to prove to F star that reduction always finishes. Which seems tricky because it so explode reduces the number of nodes, but split creates new ones. So what metric is going down isn't immediately clear to me. There probably is one, but its structure seems hard to interpret. So we're just gonna write it as a divergent function. So add and reduce given two numbers. This is divergent number. Let's just do reduce first. Okay, so do we okay, we always explode if we can explode. All right. All right, this would be a good time to have the utility that spits out all the patterns. I thought there was one such. I'm not seeing it here. We can reduce an expression. Oh well. All right. All right, we'll do not found last. So if we're finished with a new number, then we need to reduce it again. Similarly, wow. Okay. This is basically shouldn't happen. Be nice to assert that it couldn't happen. I guess no. All right, we may have to go even. We may have to go even looser on our semantics. But these ones are fine because that number just falls off. All right, so if we got to not found, then we're going to try split. And so if we get split finished, then reduce. Otherwise, I call it finished split. And not found split. All right, and if it's not found, then our original number is as reduced as it needs to be. Split. Type of pattern does not match. It's an explode result. Oh, we need to give it the initial depth. Yeah, so with fill with it thinks it needs to be all. Wow, it sure would be nice to say that that is impossible. Could we just prove it? It says okay, so we've got an R that's explode results and limited to if it's a left-right result, then depth has got to be greater than or equal to 4. Otherwise, oh, go. Oh, all right, that was nice. So it proved that automatically for us, checked it for us. So we should be able to just eliminate this case. Hurrah! So we can go back to being divergent. Nice. Okay. So let us, okay, so we need the function that adds a list. Let's just do add and reduce. Reduce, add numbers A, B. Okay, and add list. We're gonna get in trouble. So we don't know that this operation is associative. It may well not be. So let's take care to add things in the right order. Okay, so let's call this L. So if it's just two numbers, then add and reduce those two numbers. Otherwise, if it's two numbers and a tail, if it's a single number, then it's a single number. Then we add the list that's the result of adding the first two numbers and then doing the tail. That needs to be a recursive function. Okay, so that folds A and B into a shorter list, folds the two head elements into a single element, which results in a shorter list. All right, let's, all right, so we need the boilerplate that to read a list and sum them. Let's try this small example though. Oh, and we haven't done the stupid check summing. The magnitude computation. There's a lot to this. All right. This shouldn't be too hard. Three times the magnitude of its last element. All right, yes. All right, if it's a literal, then that's just literal. Otherwise, it's a pair left, right, and it's 3 times the left plus 2 times the right. We need to actually call the function. Okay. So when was the last time we input a list of strings? Nope. That's not it. Parse input. All right, so list number. Parse. All right, so we got a match. So if it's a error E, then we it's okay. Value, then take that value with the rest of the input. Parse. Oh, we need to do list of string. Why not? It's not equal. Okay, whatever, F star. You do you. All right. All right, let parse input. That's not how this goes. Open read file. All right, so we will print the number. I was wondering whether we ought to have printed each reduction step. And then we're going to print the magnitude. All right. So we got a lot of examples this time. So let's use the big one there. And let's get a simpler one. I should keep these in their right order. And what's our real input? This monstrosity. All right. I think we should add an example 0. All right. Let's start it up, see what happens. We didn't check that it's non-empty. Okay. If length input less than 1. That doesn't look right. Nope. Yeah, we got a bug. All right, so let's back up here and work through this example. All right, I'm going to make a new version of reduce that prints out every step. All right, so yeah, that'll be fine. Oh, and we do need a new line. All right, so let equals parse number string. We can do a match of both pairs. So add numbers and 1 and 2. All right. What is not equal to the expected type what? I mix up okay again? No. Let. No. Be helpful if it said what at least one of those types were. All right, I think that is a parse result number, parse result number. I really didn't like that. I can never remember which way that operator goes. Key symbols type description is less than colon. I was right the first time. Parse result number input. All right. Oh, for Pete's sake. I don't understand what the problem is here. This is a parse results number C1. This is a parse result number C2. All right, fine. If okay, if Why did I come up? So I find it easier to run Windows as my main VM. Uh, the browsers work a little better. I can play Steam games. I don't have to worry about funny driver issues. But Linux is my preferred development environment, and I pick Ubuntu just because I'm lazy and it works. I had a discussion with somebody else about choice of distro, and I fell into the Ubuntu habit a few years ago. All right. I was trying to avoid checking the errors one at a time. There we go. We can still do this. Um, okay. Dot. What did I call it? K dot value p1. K dot value p2. What do you parse error? Oh, there we go. Well, that was annoying. All right, we'll put these on hold for a second and see what happens with the example. If we try following along with the example. All right. After explode. Okay, that's good. Oh, then we explode again, which oh no, we should explode again, but we lost. I hate rebooting laptops too. You never know if they're going to come back. It is kind of weird. Used to be I was using Excel a lot more in my day job. Type, sizing things like file systems, file system structures in Excel, or Excel's a nice tool, and I never got into one of the other open source spreadsheet tools. I tried a couple of times. The other thing, although I've been using Google Sheets more often, so that reason has gone away. I haven't had to use Excel in a while. But in my old job, I would pull it up once in a while for quick prototyping hacks or computing things. All right, so it looks like what happened is we lost everything in this explosion. We really exploded the heck out of it. All right, so that looks like a problem going from in one of our finished cases or in handling the finished case. Like this looks suspicious. Yeah. Okay, those are wrong. So if we explode A, that doesn't mean B goes away. So this is a pair of finish the left hand and keep the oh no, it's a finished of pair of N and B. And then this one is finished of A and N. Yeah, so we went down, did a bunch of work, it came back. All right, let's try that. All right, better. All right, so let's try, let's go back to our, all right, dump that out. We'll re-enable our big examples. See if they look better after that fix. All right, so that one looks good. 87778677. 3 close, 3 open. Okay, that looks good. So why no dark theme? Good question. I never got into it. Or you mean on Twitch? Probably because I don't know how to set it up. Oh, I see the chat overview looks stuck. I'm not sure I can do anything about that. Yeah, I switched to chatting. I think it is stuck. I don't know. I don't know what I can do about that. Yeah, it's just the same in all my views. Sorry about that. I don't know if there's if either of you are a Twitch expert and can give me a hint. I'd gladly try something out there. But all right. Hey, so our magnitude is correct. And is this last one our real input? It is. Well, let's try it out. Amazing. Wow. It worked. Are we going to have to rewrite everything? Okay, what is the largest magnitude you can get from adding only two of the snailfish numbers? Oh, it. I wondered about this earlier. Snailfish addition is in fact not commutative. Oh, I was wondering about associativity, not commutativity. So we need to try adding in both orders. So I'm gonna depart from tradition and keep editing this file just because it's so huge. Okay. So I miss iter tools from Python so much. I have to do everything myself here. Maybe not. Maybe is there like a zip? There is. All right. Yeah, Gene, my boss, uses something other than Twitch Studio. But I forgot what it was she said. Chat settings. Not seeing anything there. All right. Seemed to work before fine on other ones, but I had a weird technical problem where my second monitor shut off and everything collapsed to one monitor and the screen sharing broke, so maybe it's fallout from that. All right, so we got a unzip. I don't want an unzip. I want a zip. How strange. I only have zip for the ML effect. Why would that be? I mean, that's stupid. You could just have the type require that they're the same length. All right. Is that gonna work? No, that's not a product. That would just give me everything paired with itself. Is there anything else in here? There. Why F star? Because it's a challenge. In previous years, I've used even less capable languages, but I am curious about. I wanted to learn more about using dependent types. So I had read the book, The Little Typer, and learned the Pi language about dependent typing and the way you can sort of prove program correctness with it. And I tried using Pi last year, but it was just too hard to get anything done. So F star offered some of the same benefits. If you can write proofs about your program behavior, you can use type, extended type checking. But you can actually extract it to OCaml code, so you can actually run it and process strings and all the other things you do with Advent of code. Pi, you really couldn't even process strings. You would have to convert them all to lists of numbers. And things like redefining addition in each file got old really fast. So it turns out that two of my current coworkers actually worked on the F-star language when they interned at Microsoft Research. I did not know that before picking it. I just seen it as sort of, if you know dependent types, here's what you should learn next. And I like the idea of it was code it was easy to extract code from it. Even though I don't actually know OCaml all that well, or really at all, I can sort of hack it once in a while. But all right, I can't believe I'm getting stuck on a nested for loop, which is really all we need. All right, find max sum. So we've got a list of numbers. We've got our primary index, uh, L. We got our second index. So the other reason I'm interested in dependent typing is the the startup I started working for, Akita Software, is inferring types from observing API traffic. And one of the things we've talked about doing is also inferring connections between different calls or between different parts of the same API call or between the request and the response. And I've been wondering if dependent typing is a good model for that. I think the answer is mostly no, because a lot of things are probabilistic or based on counting rather than a firm contract. But that's part of why I chose F star this year. But I'd really been planning to follow up with Pi with either Coq or F star or some other dependently typed language. Okay, so we need a best so far. So I'm going to use an optional type on them. Did I write magnitude as a natural number? I did. Which is kind of a lame way to handle the first iteration, but okay. Sorry, I shouldn't say lame. I should find a better pejorative. That is really a pain in the butt. I'm gonna fix that. All right. So what we're gonna do is we're gonna say if I has reached the end of the loop. So if I'm gonna change that. I've done this before. That makes it a little easier. So if I is at its length, then we return the best so far. That's the easy case. If j is at its end, then start over on the next loop. So find max sum L I plus 1. We set it to 0, keep the same best value. Okay, otherwise, all right, so if I equals j, then I don't think that's permitted. to different. All right, it says different. So increment j by 1. All right. Otherwise, we gotta sum them and take their value. And so this, by doing that, this becomes a divergent function rather than a total function, which is unfortunate. So the F star has different models of computation called effects. So what is my function called? Add and reduce. Magnitude of add and reduce index Li index Lj. All right, and we should get both orders eventually because we're going the full length of the list. All right, so if m is greater than best, one thing I learned yesterday or the day before, f star does not have a built-in max function. It has a built-in min function, but not max. Okay, so if m is bigger, then use m from now on. Otherwise, keep the same value. All right. Does it, except we need to fill in a best value, but that can be 0. All right, so we're good. Oops, too many lines. So, gonna read the input. Going to find max sum of input, start at 0, 0, 0. All right. So everything's still type check. No. If. And I put a colon in because when I'm tired, I fall back to Python syntax. All right, let's try this. Oops, that's the wrong directory. All right. These so the question is Python my go-to language? Python is my go-to language for quick hacks. So we do use it as in Akita, but most of our code is in Go, and I was at HashiCorp and programmed in Go. So I get paid to write in Go, but when I'm throwing something together, it's usually Python is my go-to language. Before that, I did some file system programming in C++, but it turns out I haven't been keeping up with C++. I know old C++, not new C++. All right, so we got the sample question correct. Let's try this. Lovely. All right. Only took me 2 hours 45 minutes. Let's so yeah, I haven't picked up either of the stars from yesterday yet. I did advent a code in Rust a few years back, actually. Um, I think that repository is still up here. Um, yeah, back in 2017. Yeah, that was nice. The Parser Combinator library, NOM, was very good. Um, I didn't get to try out any Rust concurrency features, but my solutions are up. I think I managed to get every star that year. Uh, in 2018, I did Haskell, and Haskell kind of kicked my butt. In 2019, I used a graph grammar language that I'd written myself, implemented in Python. You can see that was hard because I never got multiplication working, and a lot of the problems that year were based on the same virtual machine that had a multiplication primitive. And my Pi attempts where I got like 7 stars total from last year. They're all up there. Oh, that's right. I was gonna look at what was the how did we do on the leaderboard? Oh wow. People are having a hard time with that today, I guess. That is my best showing yet. Huh. All right. Well, I will post the solutions shortly. Thanks for staying up with me. Happy Advent. Hopefully tomorrow chat will be working again. Good night.